Hi, this is my second time to Ukraine. I was here a couple years ago at Ruby C in Kiev. It was really nice. I had a good time. I'm glad to be back. Yeah, I am going to give a talk today kind of about how, I guess, crypto mining works. I think that I kind of missed the boat on this. Maybe in 2017, it would have been a better time to be talking about cool blockchain stuff. But it's still like something that I think about a lot, and it took me quite a while to kind of understand the core of what's actually happening with especially mining. And as was said, I've worked for the last, one project that I've had for the last year and a half has been managing a kind of a small crypto mining farm in Austria, and it's weird. People kind of hate you, but you know, you gotta live. Here is kind of the inside. It's pretty ghetto. It's inside a container. There's a bunch of GPUs you can see. There are the GPUs up close with, yeah, it's super blurry, but whatever. And then this is a video actually. This is like the gaming lights. When you go in there in the dark, it's beautiful in the mining rig, but it's really loud and dries out your eyes and stuff. So it's not that fun to be in there. Here's my mining rig actually in my office. You can see there is one video card. There is a fan. So the only video cards I get are the super busted ass ones. So the fans don't work. So I've taken these other fans and stuck them and sandwiched them. There's another video card. This is a 2-card rig. And there's the other fan. It's kind of loud and awful and doesn't work very well, but electricity's free in my office, so it's nice. So this talk is going to not really be a talk. I've been trying to give versions of this talk for the last few months, and I kind of hate it every time. And so here we are. So I've thought to kind of change it around a bit and make it more of a demo than a talk. Yeah, so we're gonna do a little experiment together. Yeah, so we're going to talk a bit about an electronic currency. So where are we going here? We need to be not here. That's a bad spot to be. We want to be probably here. So that's a tiny little bit of real estate that I have for this guy. So we're going to create kind of the old school electronic currency that's going to be very centralized. It's going to have one server that runs that you can send requests to and send money back and forth between different people. And it's really completely incredibly simple, and but we're going to create I guess let's call it an e-currency right now. So what I have right here is just a Sinatra app. We start with accounts. I get 10 million of the currency at the start because I guess I'm the boss. And then down here we just have one endpoint, and it is send money, post request. You just have a from, which is a string, a name, and then a to, which is a string, a name, and then an amount, and then it just subtracts money from one of the accounts and puts it into the other account. It's electronic money. So we are going to run this in a little Docker guy here. Oops, that's not how you spell that. So it's running. Yay. That's all that matters right now. So I think that it's what it should do. I think I should know this, but it should print out kind of the accounts after a certain amount of seconds. But we actually don't really care about that right now. What we care about is sending it a request. So we have ourselves a client, which just sends a post request. We can open a pry session and use that. I'm going to make lots of weird noises while I'm typing. So we have the client, and we want to send money from Aaron to who? Who am I sending money to? What? One more time. Volodya. All right. And we're going to send you, how much money should I send you? 10 million? I'm not going to send you all my money. So I'll send you 10,000, okay? Okay. So now let's look over here. Oh, look over here. We've sent you money. That's our currency. We have a currency now. We both have money. So essentially you can go over here. I can send you more money if I want to. I can send other people money. And you can see over here that we're subtracting money and then we're adding money over there. So something that I'm going to do, I like to bring these along with me when I come from Austria to other lands, is there's this Austrian wafer cookie. It's called a Manner. And they are actually vegan. If you're vegan, you can have these as well. They're still good, though. And if someone can tell me one thing that's wrong about our electric currency, I'll give you this guy. We got with your first. Was it repeated? See, that's a bug that I wasn't expecting. Yeah, it seems fine. I think I might have just hit it twice. Sorry. You? I can send more money than I have. So say I want to send from Aaron to Volodya 100 million. Uh-oh. I have negative a lot of money. What is that, 900 million? Here you go. So that sucks. What's another problem with it? Just okay. Yeah, I like that. I'll give one of these for that. I gotta save 2 of these. Who said that? Was it? Who? Oh wow. Can we do this? Woo. Perfect. What's that? What else? No. I mean, sure, that's the thing, but that's not one of the things I care about right now. You have all your money. You're fine. Send minus 100, so that can work as well. That kind of, I'm going to consider that the same as the last thing. Okay. Okay. Maybe. I'm going to think about that one to see if it's worth the wafer thing. There's one that what about, I'm just going to throw this one out there. What about the people's names? Can I just say, Aaron can send money to anyone or anyone can send money to anyone else? There's no authentication. So I was really reaching for that one because that's the next part of the talk. Yeah, I'll give this one. Cool. Okay, so we have a problem with, first we're going to deal with authentication, and then we're going to deal with some of the other issues. So, step 2, we have cryptography. Okay, so in step 2, what we're going to do is we're not going to use passwords because passwords will be an issue once we start becoming distributed. That's a little bit of a spoiler alert. And instead what we're going to do is we're going to use public keys and private keys to sign transactions. So someone said transactions. You said transactions earlier. I think that you're going to end up getting something for something else. So we're going to create transactions, we're going to sign them with our private keys, and then we're going to send them to this server, and then we should be perfectly happy with the world. So what we have to kind of store our identities is a wallet. In this wallet, pretty much it just has the interesting parts are this public key and private key, which are you can either give them or they're generated via this crypto guy over here. The reason to, it doesn't matter. So Another thing that we have is an address. So each of these wallets has a public key, kind of an address. Instead of giving this giant public key, we're going to just base64, are we hashing it? We're base64 encoding it, so we can pass it around. It's a little bit nicer than having a big RSA key starting here, RSA key ending here. We can sign transactions. So if you create a transaction, you can use your wallet to sign that transaction, which creates a signature, which then you can use to verify that the person with the public address that is the from address, actually was the person that created the transaction. And that is happening here. We're just signing it via the transaction. Let's go look at the transaction real quick. Transaction. And the transaction just has a to, a from, an amount, and a signature. I'm using Vertis, which people aren't really supposed to use anymore. You're supposed to use dry now, I guess, dry RB for all of those fun things, but I still like it. And it is signing it's taking the from, the to, the amount, and bringing those all together, joining them together into a string, and then hashing that, and that is how we are creating the signature. And yeah, so we have ourselves some signed transactions now. And then we can go to the server itself. I think we should look at crypto real quick. Its job is to use OpenSSL to create signed key pairs, or to create public and private key pairs. And then it can also it can take plain text and a private key and create a signature. And it can also take a public key and the signature that you created and verify that it was created by that private key, that is by the owner of that public key. Yeah, and then it does some other things down here, like some fun helpers. So we are going to go now to our new server and see what's happening. So our accounts are now empty in the beginning. We're going to have to create kind of our first transaction with a signed transaction outside of it. When we start up the server, we create a wallet for that server. So it's the originator's wallet. And what I do just for niceties, I guess, I print out the public key and the private key and also put them into a different folder so that we can read them and then use them to create the first transaction. And then send money is slightly more complicated, but not really. It takes a transaction. It takes the data of a transaction instead of just a from, a to, and an amount. It also is taking the signature, which we created with the wallet. It's creating a new transaction, and then it checks if that transaction is valid, and that's where it's checking if the signature matches the public key of the account that created it. And if it does, if it's good, then it subtracts from one account and adds it to the other one. So let's see how this works. So we will go. So here's our public key and our private key that was generated in the wallet from the server itself. And it is running. So we're going to go over here and we're going to grab those public keys, or the private and public key, and create a new wallet that is based on the other wallet. So we go wallet new with those private key and the public key, and we don't have that yet. That's great. So now we have a wallet, and you can see that it has the public key and the private key inside of it. And then we want to create a transaction that's the first transaction. And the amount is 10 million. I liked that amount earlier. And I forgot to know how to do Ruby. And so here's our transaction. And now we want to send our transaction to the server. So we need to probably require the client. Lots of spoilers here. Only spoilers. Okay. and then we just send the transaction. So if we look over here, we can now see that the public key with has a balance of 10 million over here in our thing. That's our first. So let's just really quick create another wallet. So other wallet equals wallet.new. And then we can send money from the one wallet to the other one. .send. And we'll send 10,000. Okay, we got our signature, we got all that stuff, and now we just need to, we need to pick that up. So this is the fun trick with pry, if you don't know it. Underscore means the last thing that was output. So client, that's probably the most interesting thing you'll get out of this talk. Okay, there we go. And now we have, it was legit, it let it happen. We could try to send from other wallet. I don't know if this is gonna, I'm actually not gonna do that. I don't care. I don't care. I'm over it. Okay, so we have, now we have an authenticated server for everyone. So some of the problems that we have with this, we've talked, one of the things was that the server could just go down. We're still only in memory. But let's say everything is stored in a database. Great. What are some bad things that can happen with this situation now that we're authed? Anyone? Drop database. So data loss. Do you already have one? Okay. So yeah, say the data center goes down or something. Like it's, you could do supreme data loss and then everything will be gone. So anything else? That's the same as that one. Where you're there. You can create fake transactions. I don't think so. Exactly. There's another one. So the server owner has control. The server owner. I have to save 2 of these. So you guys, we're running out. We're running low here. Well, we got a couple left. I'm looking for one more thing. Anything? Replay attack? Yeah. Probably. You're too far away. Sorry. There was one in the middle. Huh? I'm going to pretend like we've already figured out deadlocks. So the thing that I was going to say was, for example, maybe the government wants to shut you down. They hate your currency. So what do? They just shut all of your ISPs, shut them down. You're screwed. Like all your stuff is gone. They make you get deleted from the data centers. It's definitely something that will probably happen. But censorship is an issue. Yeah, there is one more. Like, currently requests are authenticated by the other people, so everything is resolved. They're what? They are authenticated but not encrypted. So he's saying that they're authenticated but they're not encrypted. So yeah, so I mean, as far as privacy as well, people can see the money going back and forth. Yeah. I'll get you one. I'll save one more for you too. So what's happening here? So those are some issues. So we're going to move on. How much time do I have actually? Does anyone know? Whatever, forever I have. You guys are stuck here for a while. Yeah. So what we're going to do is we're going to look at maybe like a kind of a decentralized situation. And the thing that we're going to be building isn't going to be for money. It's going to be a little bit more interesting, possibly. Maybe money super interesting. It's going to be tweets. So it's going to keep a record of tweets, and it's going to be using kind of a sort of gossip protocol. And we're going to be sending them, so the the idea is that if a node starts up, it starts receiving tweets from somewhere. It keeps this list of tweets, and then it keeps talking about these tweets with all of the nodes in the network. And they keep trading back and forth these tweets, this list of tweets. And if you kill any of the nodes or a bunch of the nodes, that the tweets live on forever. So we are going to build a distributed tweet history server. Yeah. Sounds really dumb when I say it out loud. Okay. So what is it? We have, this is what all the tweet stuff was that you saw earlier. We have a node. And our node, every 3 seconds, it gossips. And every 10 seconds, it prints out all the tweets that it has. So we keep this, I have lots of globals here. Don't do any of the things I'm doing in these demos in the real world. It's like, it's horrible coding. It's really, really bad. So there's a lot of globals, and yeah, we're using them. We have, at least we have a safe concurrent array. That's really important here. How the Bitcoin nodes work, there is like a DNS, an address that they have that when the nodes come online, there's seed IP addresses that the nodes can connect to start discovering other nodes. So I'm kind of borrowing from that, and we have a list of a couple or maybe one kind of a seed server that's running. And I'm also, if it's the master node, then it will start up a tweeter, and a tweeter just, this is awful, a tweeter just streams tweets, and it then just pushes them onto the end of that global array from somewhere else in the application. So don't do this at home. And we have a couple of endpoints that just, so we can play around, and then we have a gossip endpoint. So this gossip endpoint is what the nodes will be hitting when they're doing gossip. They're going to hit this endpoint. They're going to send the data that they have that's just like Marshall dumped 100 times. And then they're going to compare it to what they have. And it's a very simple case. They say, if the list of tweets is longer that I've received than the list of tweets that I have, then I'm going to take that list instead of my list. So that's what's going to happen. And then it's also going to take the peers, all the peers of the one that's gossiping, and then saving those as well, so it knows that it has more nodes in its network. And then we can also, that is not for us. Cool, it's good. It's good, I'm testing this out on you guys. So yeah, I'll just show Tweeter really quick. It's pretty boring. It just does this. It pushes tweets on the end. And then, is there anything? Oh, helpers is something we want to look at as well. So here's how every works. It's really just looping in a thread for the entirety of the app. And this is what I was talking about a second ago. It just looks at if tweets exists, if it's an array, and if it's bigger than the array that we currently have, then just replace it. And peers, good, fun stuff. And for gossip, we just go through the peer list and then gossip with a peer, which just sends a request to the peer and then takes their state, updates our state, just, yeah, woo. So, we'll run our master server. And you can see, hopefully soon, that the internet is or isn't, oh wait, no, this isn't looking good. Bieber unknown terminal type is not a good error. I feel like I might not be connected to the internet, and it's impossible for me to find out. Yeah. Can I pretend that the tweets are happening? Is everyone there? The talk is real boring, and everyone's on the Wi-Fi right now, so it's bogged down. Is that what's happening? Crapola. There's no way for me to see anything. What's going on here? I don't think so. Can we just imagine? No, I don't want to just imagine it's working. Well, I don't know what my plan was for not having internet in this case. Like normally I have a backup plan, but I feel like this time I really came to the party without my pants on or something. But the problem is I can't even get to the thing because my window's so goofy right now. We're starting up peers. We have no master, so they're like freaking out right now. They're like, we don't know what to do. We have no, where's our master? We're just peers. That's all we are. Who cares about us? Your tweets, Bieber, unknown terminal type. This is really what's happening right now. Yeah, so you can see that normally everyone would be having tweets from the master, and you wouldn't have just sat for 7 or 10 minutes and watched me try and do the Wi-Fi. But it doesn't work. But if you download this repo, if you don't have a QR code reader, I'm really into QR codes. I think that they're the coolest thing. If you don't have a QR code reader, you might want to download one because there's a QR code coming at the end. So just as a warning there. But I think people have data. People with data who, yeah, cool. So that just happened a lot. Yeah, so we had a distributed server that you really saw how it was working. And so one of the big problems that we have, I don't want to do this asking question game anymore because there's a lot of good answers and never the one that I want. So I'm going to tell you that one of the big problems with if we used money in this decentralized way, one of the problems would be preserving the order of the transactions. So it would be really hard to tell kind of if you had one transaction that you sent to one country, one side of the network, and then one that you sent to another side of the network, it would be really hard to be able to find out when everything came together in the end, which one came first. So one bad thing that can happen with that is what is called the double spend, where I spend money over here and someone sees it and they give me I don't know, what am I buying? Like a Lamborghini. I always like to use Lamborghini as an example because it's such a crappy cliche. So I'm buying a Lamborghini. Not anymore, actually, you're buying like a Fiat now because of the market. So I'm buying some kind of a small old used car and I'm paying for it with some sort of a currency. And I pay for it over here and send it to someone's address, but then over here I send the transaction to another part of the network. And these people over here see that I've paid them, so they're like, I'll give you I think a Fiat Panda. I don't know, do you guys have Fiat Pandas here? Probably not. It's a crap car. So I get it, I drive away, and then right about that time, the transaction from over here comes back, and all of these nodes are like, what's going on? We have a transaction here that says you paid this much to this person, and a transaction over here that says you paid this much to yourself. What do we do? And there's no way to kind of decide which thing came first. You could use timestamps, but timestamps, you could just lie and say that the thing happened much longer before. And how can you really trust that it didn't happen long before? It's a different network. It took a while. Yeah, so one of the problems that actually the Bitcoin white paper solved was trying to make these things kind of take longer. So you want transactions to be spaced out a bit. And what Satoshi decided was that time would be 10 minutes. And so and the way that these things would be timed out is by using something called proof of work. So this is mining. This is the title of the talk. And what mining is doing something that takes a significant amount of time, that you can prove that you spent some sort of time or energy solving this problem, it takes a long time to solve the problem, but it's very easy to tell whether you solved it or not. So what they're using in Bitcoin is SHA-256 hashes, and trying to, what often people say is that you are trying to create a hash that has a certain amount of zeros at the beginning of it. And in reality, all that means, since it's a 32-byte hex hash, having zeros at it always has a fixed amount of digits, or characters. So having a certain amount of zeros at the beginning of it just means that it's a smaller number than the maximum number that that hex can be changed into. In reality, you're not trying to find out how many zeros are at the beginning of it. You're just trying, there's a random target that's picked, and you're trying to randomly guess a number that's below that target. So we're just going to do a really basic sample of just a proof of work script. And it takes a target. We're going to go the easy way and say it's just the amount of zeros at the beginning of the hash. It takes a target. We're going to say 1 0, 2 0, 3 zeros, 4 zeros, 100 zeros at the beginning. 100 zeros is impossible, sorry. And then we try to find a combination of some kind of data. So maybe a message that you're sending, or some kind of like, maybe you hash a whole document or your identity. You hash it together with a random number or a random character, and that should hash out to be something that has a certain amount of leading zeros. So it has to be below a certain number. The more leading zeros it needs to be, the longer it's going to take, the more calculations you'll have to do on average to guess the number. So we're going to start off here pretty low with with 2 leading zeros. And yeah, see how that goes. What's happening? Yeah. There's faster ways to do this. Okay, so what does our API look like? We go minor equals, and we're going to start off with 2 leading zeros. Find nonce, and we're going to find the nonce for a message of hello world. So you can see it found the nonce. There are the 2 leading zeros that we care about. Is this visible to everyone? I should have asked that probably a long time ago, probably. It took 851 different nonces before it found the right one, and our nonce that we start with is what's up pivorak, which is probably pronounced horribly. So we can do it again with exclamation point or something. It changes it slightly. It only took 220 to guess that time. So let's do with 4 leading zeros. And also another thing that happens at every 10,000 iterations, you see a little dot. So you can see like things are happening. See, this time it took 19,000. It's the same thing. 38,000. And now let's go 5. We're getting a little crazy here. Whoa. Whoa. And you can see that there are 5. Whoa. Yeah, it's a good word there we got. So, and it can also take not, so what I'm not going to do is, actually, we'll just do it real quick. The reason that this doesn't work very well with the leading zeros is because if you just move to another, the next 0 down is a factor of something. Someone who's better at math than me can tell me what factor. No one. This deserves a thing. Huh? Yeah? The power of what? What? No, sorry, like how many, so if you, yeah, 16, so to the 16th of, 16, come on, someone? Okay. Yeah. Okay, so this takes a while. You can see that. So you can actually, if you're just going for a target number, not a number of zeros, you can get it a little bit more closer to being not having to wait a factor of 16 to yeah. Woo! Okay, so that's just, we just did some proof of work. Great. It's the longest talk ever. And so it's good. It does slow the system down. So you're going to be less likely that you're going to have these split brain kind of things where this part of the network is saying something and this part of the network is saying something else. But and it also, like, Something else that you can do is spam transactions, which you're just sending a ton of transactions around back to yourself and back. And it also makes it so, yeah, it doesn't do that actually. I lied. And the problem that we have still, I'm going to give one more thing away. What's the problem that we would still have? I'm probably asking a question that doesn't. It was something that I talked about, one of the benefits. I'm just going to tie my shoes right now. I stepped on them earlier. Kind of how we're going here? No one? So one of the important things we needed to do also was to preserve the order of these transactions. We were going to maybe do timestamps, but timestamps suck. So the solution that we're going to use that the Satoshi's white paper used was to create a blockchain. So we are going to build a blockchain now. We love blockchains. Love to hear the word over and over again. Put it on the resume. So in the blockchain, wow, I have slides now. There they are. Look, where are we? Where are my slides? This is the truth here. So we have an ordering problem, and what we're going to do to solve that is we're going to put these transactions into something called a block. The block is going to contain the hash, like the hash that we just saw, of the previous block. And that hash of the previous block is created by taking the transactions inside of it and all of the other information about that block, hashing them together, and also hashing them with the nonce that proved that you had to do work to build this block. So we're going to point to that block. Fantastic. So we're going to keep building blocks, block, 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 block. And since they're referencing the last one, if we change anything in that block back there, then it totally knocks out all the blocks after it. They are not validated anymore. And for the split network problem, like I said, we're going to slow it down a bit. For double spending, it becomes very, very expensive to attack the network. I think these are the, nope, not yet. And we'll go back to that in a second. And another rule is the chain with the most work in it always wins. So if you're going to have situations where two proof of work problems are solved at the same time with two different blocks. So part of the network is going to believe that this block is the next block in the chain, and then another part of the network is going to believe that a different block is the next block in the chain. But it's very unlikely that you will find the next two blocks or two blocks at the same time after that. And it's even way less likely that it happens 3 times in a row or 4 times in a row. But like generally people wait 6 times. So it's like, it's almost impossible for 6 blocks to happen at the same time. So the rule is always, if you're a miner, always go with the block with the most work in it. And it's also a good bet because if you bet on the loser, then you put a bunch of energy into looking for, it's a total lie. It's like minus 10 minutes probably. Yeah, cool, yeah. Woo. Yeah, so the chain with the most work always wins. And the blockchain's always forking. This is kind of like more of a picture of what I just described. These 2 blocks are found at the same time, but this next block was found before the next block that was built on top of that block. So the miners say, whoop, this one. And then it happens and it keeps happening. Sometimes you get 2 that happen in the same time, whatever. So the rule is to follow the longest block with the most work. And the whole double spending thing that I was saying earlier, there's a problem called the 50% attack. And the 50% attack is if I have more than half of the kind of hashing power of the entire network, it's possible for me to double spend and then create my own kind of secret blockchain. And then once people have said, okay, it's time for you to send me the fiat panda, and I have it, then I can release all of my blocks to the rest of the network. My chain will be longer, and then everyone will pick it up with my not buying the panda. And then they don't have any money, and I have my free car. There's something I'm missing in that description, but whatever. So We're building blocks. The guy below is building blocks. This was back when the market was better, when I had this picture. And so we're building more blocks. We're building more blocks. The bad guy's trying to catch up with his double spend, but we are faster because we have more than 51% of the hash power, and the miners always go with a longer work proof, so yay, we win. That's great stuff. And 51% attacks actually happen. It happened to Bitcoin Gold, or one of the Bitcoins. Bitcoin Gold, I think. It happens to, is it Verge? There's one that's really awful that it happens to quite often. They just don't fix it. And yeah, so it's a real thing. And something with Bitcoin, it would cost just an unimaginable amount of money, not unimaginable, but a lot of money to do it. But yeah, so I'm going to see how quickly I can go through this. You thought it was over. So I got to move this thing away from just where my nostrils are. Oh, wow. There's no way I'm going to be able to get through this in a couple minutes. Maybe I will. Wow, there's more globals even. So you can, essentially you send a transaction. Here, actually the interesting part of this, who cares about the node? So the node essentially does the same thing as our tweet node. It just, instead of the tweets, it has a blockchain, and it replaces the blockchain on other things. Each peer that grabs a blockchain checks if all of the spends are valid. Great, perfect. And we have a block. There it is. So here is our block. Our block has, when we create it, we give it the previous block, which it pulls the block hash out of. We give it a transaction. This blockchain, each block only has one transaction in it, just to keep things simple. And it has a target, which is the current number of zeros to have at the beginning of the proof of work that you're doing. So normally what happens is a miner asks for transactions from a node. It creates a block with those transactions. The first transaction is money that goes to the miner. It's like the 7.5 Bitcoin now, 12.5 Bitcoin. God, I'm good at this stuff. The 12.5 Bitcoin that goes to the people that do the mining. That's the first transaction, then whatever, a bunch of other transactions. It hashes all the things together, and then it tries to find the magic number. When it does, it puts it together with the block, sends it to the network, and then gossip, gossip, gossip. Everyone says that's a valid block, and it goes on to the end of the chain. In our case, we just have one transaction, and the block mines itself. It's self-mining blocks that we have. It's pretty amazing. So that's a block can check if it's valid by checking the nonce, and the nonce is the transaction hash mixed with the previous block hash mixed with the nonce, compacted and joined together. Yay. So there's one more possibly interesting thing. Our actual blockchain. We initialize it with a wallet, which creates the Genesis block, so the very first block that has no from address. It just some magic wallet gets a certain amount to start with. And to add to chain, if we add a transaction to the blockchain, it creates a block, and then that block mines itself, and then it adds it to the blockchain. If all of the spends are valid, and checking if the spends are valid is here, and it just checks if any of the balances at any time are below 0. Yay. So we have a blockchain. I wonder how many more times I can say that. And is there anything else? There is nothing else here of any interest. So we're going to run our blockchain real quick. So that was our wallet over here. So we have one transaction. It's the original transaction in our blockchain. And you can see that the other nodes are also picking up that transaction. We can Jesus Christ. Okay, we have a wallet. What is this one called? Genesis transaction. Wow. Okay. Oh, God damn it. How much time is left? I don't even care. I don't even care anymore. I'm done with this. I don't even know how to send anything to it. I've forgotten with all the other crap that's going on. I forgot that. Yeah, whatever. I give up. It's over. There's a way to send transactions to this. Oh, you know how I was doing it before? I was doing it. Post. Faraday post. Do that with the transact. I think this is it. It's not working because we don't have TX. It's great. I love it. Okay, I hope that freaking worked. It didn't because this is happening now. It's just really invalid transaction. See, that's good. That's good. That's like the blockchain is like, hey, you can't do that. It's invalid. It's bad what you're trying to do. Yeah, but anyway, Jesus. So this code that normally works, I think, is available on the GitHub. I'm not going to tell you about proof of work alternatives because I don't have time. There's other ones like proof of stake. Proof of stake is a thing. Proof of burn, proof of identity, this guy, and proof of capacity. And as I told you before, there's a QR code. Thank you. It's a fucking great time. Woo. Yeah. So if you,
The second
a couple people have QR code readers. I love it. It's awesome. Yeah, cool. My phone doesn't have one. I don't have an iPhone though, so I guess that's
the second part of the presentation was
question.
Pretty
Yeah, great. I love
quick.
how it went.
Do we have
I'm really
questions,
happy about
guys? Questions?
Is that beer ready yet, or is it
No.
Okay. I feel like I need a.
Okay,
vodka
scan
or
your QR
something.
codes. Okay, we have.
Anyone have any
question.
vodka
Yeah.
in their bag?
When you talked about double spend and if somebody has this 51% and so on, is it possible that when those blocks are built, are they different blocks from the other branch and that there will be transactions which are not valid or dropped? Or
No, so that's something I probably should have gone over a little bit more is when there's multiple times where the transactions are validated. So when you send a transaction to the nodes, they validate it and they say, hey, is it possible, like, does this person have the money to spend this? Is it a valid transaction? When the miners take them, they say, is this a valid transaction? The miner checks from all of the blocks before that it's building on top of and the current stuff in its block. It might have like double spends in the current block. It will just throw those in the garbage and say, this is invalid. I won't add this to the block. So another part of that is that the block that you're building is referring to the previous block that it's built on top of. So you're always referring back to a valid block that you're building on top of. So you can't take transactions from somewhere else. So So I think maybe that answers it. Cool. You get one. You get one. I don't have any more actually. I got you and then this guy back here. Huh? Yeah?
1 second, I'm bringing him.
Yeah, sorry. Don't ask it yet. She got a microphone.
I'm lost my zipper. I'm sorry. Okay, I
cool,
got
man.
a question. My name is Gregory, and thanks for presentation.
You're welcome.
Do you believe in blockchain, in cryptocurrency, or maybe some guys from a federal bank? It's just a simple question, but are you using some of currencies, crypto?
Yeah, I own some, and I'm my full-time gig soon is working for a company that does a lot of stuff with like the Ethereum Foundation. So I'll be building lots of dApps, the things that everyone likes to talk about but no one uses. So I'm actually working on a dApp right now. So yeah, I mean I'm in it. I'm deep in the stuff. So I think it's super interesting. Like it's a fun, interesting technology that you can. There are lots of possibilities, but I mean it's not. No one's doing. There's not a lot of stuff I'm seeing that's super great, exciting.